It's taken this
Mm.
long for me to figure out that, oh, I've been designing buildings looking at the past and I need to be looking at the future because that's where this building is going. It's not going to the past. So it's never going to be able to experience 1970 or 1950. It's going to see 2050 and 2125.
Hi, everyone. Welcome to the Climate Confident Podcast. My name is Tom Raftery, and with me on the show today, I have my special guest, David. David, welcome to the podcast. Would you like to introduce yourself?
Sure. Yeah. Thanks for having me. My name is David Sellers. I'm the principal architect of Hawaii Offgrid Architecture and Engineering. We're located on the island of Maui in Hawaii. And probably why I'm here is because in 2020, we were the first architecture firm in the world to commit to only building new buildings that are net zero at a minimum. Ideally, they're off grid. And what we're really striving for is carbon sequestering.
And why? As in, what made you decide this was something you wanted to chase down and do?
Well, I guess it has to do with part of my origin story. I grew up in an oil field originally in Texas, and I grew up enjoying the outdoors, loved to camp and fish and hike. The land that I really grew up on it didn't belong to us, but we got to enjoy it, is now a strip mine. So it is a coal strip mine, and that's pretty devastating. I've watched it over the years of my life. Secondly, I spent the summers of my undergraduate architecture career in Alaska working on commercial fishing boats. I grew up as a mechanic. Subsequently, 20 some odd years later, after a little mishap in Alaska, we hit an iceberg on my boat and we sank.
Oh,
20 years later, I go back to Alaska. I was first inspired and got into off grid architecture because of my time in Alaska working on commercial fishing boats and dealing with water systems and generators. I knew how beautiful nature was and how terrible it could be when humans destroy it. And so I
mm.
thought, okay, well, there's got to be a better way. And buildings are a big part of our built environment, our energy consumption. And so I like building stuff. Ultimately, though, since I've been practicing architecture, I've seen massive changes in the climate and the environment that I'm trying to design buildings for. And it's troubling. And so we wanted to make a stand. It's also a way for us to seek out the clients that are like minded. I don't want to proselytize to people and try to convince them of something. I just see something that is not hard to see if you've been around for 20 years practicing this. The weather's different, and we need to figure out how, as an architect, if I'm designing a building today that's supposed to last 100 years, what's the climate going to be like in 75 years? Is this building even going to be relevant? In short, I do what I do because I think there's a need for it and I can see it through my own experience. This isn't something that I'm consuming from media. This is something I can see every single day. We see changes in the climate, and someone that is into climate responsive design, I've got to take notice and I've got to respond to it.
And how did a Texas boy who worked on fishing boats in Alaska end up in Hawaii? Did you take a wrong turn at the Valdez?
Luckily, I've always had to work. It's been a huge educator in my life. I was living in Holland. I ended up doing my master's at Technical University Delft in the Netherlands. And I just finished my thesis. I was going to spend 6 months and travel to all the places in Europe that I didn't get to go to when I was living there for 3 years. A friend of mine sends me an email and says, "Hey, I thought about you because I saw this job posting and you're the only person that I know that has the skill set to do this." And I was like, "Oh, that's interesting because I'm not looking for a job." And so I looked at the job and then someone was looking for someone that had boat captain experience, scuba diving experience, heavy machinery operation, maintenance and management, construction experience. And one of the big things that they were needing was they needed help with rebuilding a runway in the middle of nowhere. And it was a runway that was built in World War II as part of the war effort. My grandfather might have built that runway. I thought, well, that's interesting. So I just shot them my resume. And I had spent years doing remote construction in remote locations, basically to save money to pay for my grad school. And so I had experience from Alaska and extensive experience after that. And so they shot me an email back. We had a Skype meeting. And I think 2 weeks later, They said, would you like to come to Hawaii for a week for an interview? We'll fly you from Honolulu down to Palmyra Atoll, and that's where the job is. And it's with the Nature Conservancy of Hawaii, and it's a national wildlife refuge and a scientific research station supporting Stanford, Scripps, University of Hawaii, all kinds of great universities doing great research. And I looked out the window. I'm in Rotterdam. It's 50 degrees or 10 degrees, spitting rain and dark and cloudy. And I was like, I've never been to Hawaii. There's no obligation. And they're like, no obligation. Expenses are covered. And I was like, I'm there. And so I went, and it was like falling in love with nature again, seeing such a remote, uninhabited place on the planet, the beauty and the health of the marine ecosystem and the reef system was I've never seen anything like it. I've dove before in the Red Sea and other places, but it was just magnificent. I thought, well, this is an opportunity for me to one, hone my off-grid skills in a real place where it's not oh, we'd like to do this. We have to do this. And I'm supporting science and research that can benefit all of humanity. And so it was a great opportunity, and it was an adventure. I've never shied away from an adventure. And so I did that for, I think, almost 5 years until my wife and I had our daughter. And I thought, well, I probably can't commute 1,000 miles to work anymore. Sometimes it's a 6 or 7 day sailboat ride or small plane across 1,000 miles of ocean. So we settled down to live in Maui, and I started Hawaii Off-Grid with my partner, who I'd met through working at Palmyra. He's a civil engineer, and we have very like-minded values and ethics and believe in trying to do good things for the environment and for the community. Here we are, 10 years later. We just celebrated our 10-year anniversary, and we're really proud about the work that we've done.
Congrats. And from your perspective then as an architect, how has the climate that you're designing for changed compared to when you started out 10 years ago?
What's interesting is that I realized, and this is very recent, I was fortunate enough to give a talk at the International Network of Tropical Architecture. They said, talk about whatever you want to. This is about housing and climate change and tropical architecture. And I was like, wow, okay. And what I had realized over the last year or so that was sort of in my subconscious, I have been designing buildings on a historical platform. So when I was in school in the 90s learning about architecture, I learned about passive architecture design strategies. If we think about the technology that was available then, the technology that's available now, it's very, very different. But the curriculum is based on experience and information from the past. Mm-hmm. So I'm consuming that then in the 90s, and now we're in 2025, and now I am purveying all of that knowledge and synthesizing it into buildings. But I realized, you know what? The climate was very different. I've seen these things, as I just mentioned, seen examples in my own lifetime of massive change. I was able to be on a climate action and resiliency committee for the county of Maui a few years ago and helped to develop the strategy and data and information for our climate resiliency and action plan for the county. We hired a climate scientist to crunch all of the meteorological data historically collected for just Maui County. Really troubling things came up that I saw in my own practice. One of them was that since 1950, the prevailing winds, the trade winds, which if you live in the tropics, the trade winds are very important, have shifted over 9 degrees to the east. And you think, oh, well, the wind's coming from a little bit different direction. Is that a big deal? Well, it is if for over 150 years you've built infrastructure that collects water for your farming and for domestic use, and you've put infrastructure in a certain location, which we're dealing with rain shadows. So if the wind was coming this way and it's bringing the moisture off the ocean and it hits the mountain, the backside of that mountain is dry. Now you rotate 9 degrees around, and so now you have a new rain shadow. And so this was something that for me, I had learned 5 years ago, but it never really sank in. Some of the other data that we had, the Kahului Harbor, where we have the most sea level and tidal datum, it has risen 5 inches. That's a massive amount. That's a lot of hydraulics if you understand the power of the ocean. The other thing that I think is very interesting is that we're having 50% fewer trade wind days, and we're having 30 to 40 days more a year over 90 degrees. So if you're designing houses and you're trying to use passive design solutions, you're doing it with the understanding and knowledge of weather that is no longer accurate. So we've already seen 2 degrees Fahrenheit of temperature rise since 1950. If we go forward and we look at 25 years in the future, 2050, we're going to see another 2 degrees. That's the trajectory that we're on. I'm designing a building that's going to last for 100 years. What is the climate going to be? So in the last year or two, I started to think about this and I was like, this is interesting because I don't need to be designing for the climate with the data that we're looking at from the last 100 years, average temperatures, average rainfalls, typical wind direction. I need to be thinking about what it's going to be like for the majority of its lifespan, the building's lifespan.
Mm.
21, 25, 100 years from now, there will be some buildings, most likely, that I've designed that are still being utilized. The temperature at that point will be 7.2 degrees Fahrenheit higher than it is today on average. The average temperature change differential between daytime and nighttime in Hawaii is 7.2 degrees. So now you're thinking about a building that's almost in a different climate. It's interesting being in Hawaii because I get to practice architecture in the most microclimates anywhere on the planet. We can be working up at 8,000 feet and it's alpine, and we could be working on the leeward side of the island and it's 10 inches of rain, basically a desert. We could be working on the jungle where it's 100 inches of rain. Like, it's really interesting. So we're really tuned into these differences. So if we're tuned into those differences at geographic locations that are around us, we have to be tuned into the climate differences in the future and start to put that into our designs now, or we won't be relevant. Our buildings won't be relevant. So it's complex, but I feel lucky to have sort of figured it out. So now there's a few things that are really interesting, like in the last 5 years. 2015 was the last installation. We designed a large microgrid in 2014 and we had lead acid batteries. That was it. We were on the cusp. We're like, oh, do we use these new lithium batteries? Oh, they don't have a track record. There's a lot of money. We're not comfortable with it. I wish we would have for that project because since then the batteries have had to be replaced. In the last 10 years, we have only installed lithium batteries. That is huge. The price for lithium batteries has reduced over the last 10 years by about 80%. Solar systems have gotten more powerful, more capable, more ubiquitous, and it's really attainable for anyone at this point, especially if you're talking about a new building where I can roll in the capital cost for that energy system into the mortgage of that building.
Yeah.
And then I'm saving you hundreds of thousands of dollars over the lifetime of that energy system. But with the technological sort of improvements around air conditioning, so heat pumps, for example, the availability of them, we have them now. They were more popular in Europe and other places in the world. Until about 10 years ago, we really didn't have access to them in the United States. So the availability of heat pumps, the reduction in cost of heat pumps, the reliability of them, we can now have off-grid buildings with climate control through heat pumps. And now with electric vehicles and the power and the reliability of energy systems, we can have electric vehicle charging, we can have air conditioning, we can have irrigation and potable water pumps, everything that you need and more. Most people don't have all of these amenities. We can do that with off-grid energy systems at a competitive price to not having any of that. So it's nothing that I've done. I just happen to be in the right place at the right time with the right interest. And now we have this opportunity for us to show sort of the world what you can do, what's available, and that it's not a big deal. So what I'm trying to do on a day-to-day basis is provide an example of beautiful architecture. Number one, what I want is for people to say, okay, there's beautiful architecture out there that I really like, that touches a part of me, and that's what I want. And oh, by the way, it's off grid, but I'm hoping that it's going to be indicative of all building moving forward. Right now, today in the world, about 30 to 40% of all carbon emissions are coming from the operation of buildings. As an architect, I've inherited and contributed to that legacy. 10 to 12% is building materials. And then about another 20% is transportation. So for people to go from their houses to their jobs to schools, we design neighborhoods. We have these conversations with our local governments about how we should urban plan. So if I have the ability to influence about 50% of our carbon emissions, I have to do something about it because I've seen what those carbon emissions are doing. And I feel lucky to be able to do that.
Sure, sure, of course. And what are then best practices in designing a house that is off grid? Are there huge differences between designing one that's off grid for that kind of alpine, very high or very cold, maybe somewhere in the Nordics? Because I know you're based in Hawaii, but alpine is global,
Sure.
and temperate would be pretty global as well. And you said you've got all the biomes there. So what would be the main differences between them, and what would be best practices in designing houses that are off grid?
Yeah. And that's really one of the interesting things that I feel lucky in my career to be able to have seen change and have the ability to influence how we think about it. So historically, we think about passive design. Now I think about active design. So passive design is where we orient a building to where it responds and can control and take advantage of the solar path, how the sun travels. Okay. So typically, as just a rule of thumb, if we can take a building, we can make it more linear and we can align it east to west, then we have a small facade on the east. So when the sun comes up, we can't really do anything to stop solar gain. And then on the west side, again, when the sun goes down, it's below our roofs. It's really hard to control solar gain. But if we minimize those facades, then we lessen that effect. Then we have a very clear southern facade and northern facade where we can then control the light. We can control the heat gain. So in an alpine setting, we want to encourage that solar gain. We want to trap that heat inside the building. In a more arid, more temperate tropical environment, we want to stop. We don't want any of that heat gain. So we want to open up to the north side, get good natural diffused light in, and limit the exposure and the openings of the facade on the south side. So same sort of alignment, same sort of thought about site placement, but they're just opposite if we're dealing with a more hot climate or as opposed to a cold climate. And then we want to adjust for the topography, of course. I try not to use bulldozers. We try to work with the existing topography. It creates a more interesting building that's more set in its place. And then we take into factor the wind direction. So we want to be able to cool the building if we need to cool it, or we want to be able to protect the building and its immediate surroundings for the inhabitants if we're trying to stay warm or avoid wind-driven rain, things like that. Now, when we're thinking about off-grid, we've kind of changed the way that we think about solar and photovoltaic design, because in the past, when photovoltaics really were becoming more commonplace, it's, oh, you point your solar array to the south. That's where the sun is most of the time, right? But in off-grid, because we have to now take into consideration the performance of the equipment, your batteries are lowest in the early morning. So I want solar panels, a portion of my solar array, I want it facing due east, so that as soon as the sun starts to come up, it doesn't necessarily charge the battery, it stops it from depleting more. And then I want to have some solar panels facing due west, so that until that sun goes down, I'm still collecting as much energy as possible and extending the period of time to where the batteries are not depleting. So we try to think about that. Now that's influencing our roof shape, where our roof angles are pointing. And then with that, we also do a lot of rainwater collection. Harvesting rainwater is very important, especially water is an issue everywhere. We have a real problem with water in Hawaii. People probably don't know that, but we've had stage 3 water restrictions as of late. The start of the PGA golf tournament has historically started on Maui. That tournament was canceled this year because we don't have enough water to irrigate the golf course.
Wow.
So if we're in a more arid climate, Then we're thinking about the strategy of designing the building. We want a large roof area for a collection area. So that means, are we going to have a 2-story house or are we going to have a 1-story house? What's that shape? What's that mass going to be like? Well, if we don't have much ability to collect water because we're in a low rainfall area, we want that building to have a large roof. If that's the case, then it's probably a hot area. We want that building to have large overhangs to protect the facade, to control the solar gain. And so now our first design influences are from nature. Listening to the client, and the client says, "Oh, I like Mediterranean architecture." Well, Mediterranean architecture developed over thousands of years based on the materials that were available, the climate that they were in, and the cultures that created it. We're trying to do that here, and we're using the climate and what's available around us to do the same thing, but in a new context. So being responsive to the design now, but also climate responsive in the future is what we're trying to take into consideration.
And then what about things like the materials that you use? Do you work with recycled or reclaimed materials in your designs?
We do. So this is rather timely, but over the last 10 years, we've been working on some of our own building products. Our office is located in the historic Pauella Cannery. It was a pineapple cannery that was built in 1926, continued to can pineapples until the late 60s, and then it was a derelict building. Now it's makerspace. We're one of the larger tenants in the building. 10 years ago, when we first opened our office, I went out to the dumpsters to take the trash out. I opened the dumpster and it's full of styrofoam. EPS, expanded polystyrene is the technical name. I was like, whoa, that's crazy. I go to the next dumpster, I open it up, and it's full of EPS. I'm like, oh my gosh. So what was happening is we have multiple surfboard manufacturers in our complex here, one of the largest on Maui, and 2 times a week they take the trash out, and it's a lot of this styrofoam. And it goes to our landfill. We have a nickname for our landfill on Maui. It's called Mount Opala. So Opala is the Hawaiian word for trash, and it's one of the highest elevations in the Central Valley of Maui. When you land the plane, you're like, oh, wow, look at that little mountain. That's not a mountain, that's our landfill. So I'm looking at these dumpsters, they're full of styrofoam, and I'm like, there's got to be something we can do with this. This is valuable material. I had been aware of insulated concrete forms just through my work as an architect and a builder. And so I said, how can we use this to make a building material? We started doing research, we started experimenting, and we ended up making what we call surf block. So surf block is an insulated composite concrete form where we take this waste styrofoam, we grind it up, and then we mix it with a Portland cement slurry and some other additives to help it flow and bind. And we make these big blocks that we then stack to make walls, and then we fill with concrete. It's similar to using CMU block or cinder block, as some people call it, but it uses a third of the concrete, and it's about 5 to 6 times more insulative. We can get an R40 wall system. On top of that, when the wall's finished, it's mold and mildew resistant, which is really important in the tropics. It's also fire resistance, which is really important now in our community. So having non-combustible materials. On top of that, it is impervious to seismic and high wind events. It's 300 to 400 times stronger than a typical 2x4 framed wall, which most of our houses are built out of. So we can provide a locally sourced material that's offsetting waste going into our landfill, that's high performance when we're dealing with a warm, hot climate that's getting hotter. We don't necessarily design buildings for passive design anymore. With 50% fewer trade wind days, the trade winds are coming from a different direction, more days over 90 degrees. It's not practical. We need to be actively air conditioning these buildings, so we need insulated buildings. The more insulated they are, the more efficient they are, the lower the cost for the homeowner. So we've been able to produce our own blocks, and we're building our 5th house now in Lahaina as a fire rebuild, which we're very proud of. And so it's going to be a non-combustible, fire-resistant home, highly insulative because Lahaina is very hot, and it's going to be here for a long time. So that's one of the ways that we're thinking about utilizing recycled materials that are found locally. We're using waste from surfboards, which surfing was invented in Hawaii. It's now a global sport that's exported to the rest of the world, but we're able to capitalize on that part of our culture and that part of our economy and do something good with it. We're limiting that waste. So right now we can build about 20 houses a year just with the waste that is given to us twice a week, like just brought to us. We're able to make 20 houses a year. And if we open that up and we start to look at taking the consumer styrofoam from when you buy a new TV, all the stuff that you get on Amazon, lots of times is packed in styrofoam. So there's a lot of opportunities there. And we're also developing now sheet insulation. One of the unique building characteristics of historical buildings in Hawaii is what we call single wall construction. So it's basically where you take a 2x6 and instead of lining them up and then making a cavity wall system, you have 2x6s that are just put together and nailed. So you get a 1.5 inch thick wall. There are thousands and thousands of these houses. They don't have insulation, obviously. People go and put window unit air conditioners in them because it's getting hotter and the buildings don't perform and they're not as comfortable as they used to be. Window unit air conditioners are terrible energy consumers. We have the highest cost of electricity in the world. On Maui right now, we're at 42 or 44 cents per kilowatt hour. The average in the United States is about 12 cents a kilowatt hour. So we have economic reasons to be more efficient, high performance, and it saves people money. We have to find sort of capitalistic or consumer, we have to find ROIs, and it has to save people money to make these changes. So we're able to couple all of these things because of the unique circumstances that we're living within. Also, Hawaii is a fantastic example for the rest of the world. As an island, the ratio of coastline to our sort of land mass and that sea
Mm.
level rise is affecting it more than anywhere. The fact too that we have to deal with this energy issue. We also now have an acute housing crisis, and the fires that we've been trying to recover from in Lahaina, they were brought to us by global and local climate change. We've changed the ecosystem. We've changed the native plants that were there. We've taken down the dryland forests that were less susceptible to fire. And so we're seeing it on a local level and we're seeing it on the global level. So all of that to say, recycle materials, we have a wonderful opportunity that we're taking advantage of. I won't say it's the greatest strategy for a small business, but it's something that we feel we have to do. So it's a pet project and we're making it happen. And I think, again, it's creating a sort of modern, present day vernacular design because we're using materials that are available to us.
Looking at all the projects you've been involved in, what design choices do you think deliver the biggest real world resilience benefits?
Hmm. It's kind of everything, right? Because we are susceptible to earthquakes. We're a high seismic zone because we have one of the most active volcanoes just down the street. We do get, unfortunately, hurricanes. Rarely do they direct hit, but they affect us greatly. The fires in Lahaina a few years ago were
Mm.
driven by hurricane force winds of a hurricane passing very close to us. So building resiliency has to have a number of different things. One is that the people need to be able to attain it. We've had this world where we have been living sort of in an idealistic fantasy where we need to continue to improve, 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 and think about safety. We have people that are devoted every day and they do a wonderful job of thinking about new building codes of how to make buildings safer. The issue is that we also, as a studio and firm, part of our mission is to do community work. And one of those community works that we do is dealing with the homeless population. We have a really high homeless population in Hawaii. A lot of that is driven by the availability and the cost of housing. So housing has gotten more and more expensive because we keep putting more and more requirements. I make this analogy. Very wealthy people will watch the Category 5 hurricane through their big glass hurricane proof windows, drinking their martinis, while the rest of us blow by in our tents because we can't afford to build a house. Resiliency has to first be economical. So you have to be able to provide a quality residence building, whether it's a house or a place to do business. You have to be able to provide that at an attainable level where people can afford it. And then it has to respond to the climate. You cannot pump all of your operating expenses into maintaining the climate comforts to operate that building. It's just not possible. So when you're dealing with the highest cost of electricity, that's a huge input. So for a small
Mm.
business, that's a huge expense. So how can we limit that expense? How can we make that building perform better? That's part of its resiliency over the long term. In the United States, at least, and it's maybe not as bad in Europe, but our average lifespan for a commercial building is 60 years. Part of that reason is because it's not relevant in 60 years. You either need to do a massive remodel, alteration, expensive, ends up lots of materials going to landfill. Maybe the building wasn't designed very well to begin with, so we have to deal with that too. But that's part of resiliency. So the relevance, and that's why we have to look in the future. Will this building be relevant in the future? That's part of resiliency. Will the building be able to help you when the climate is different? So high performance, so structural performance, energy performance, there's all aspects that are baked into resiliency that we have to take into consideration. The thing that I'm worried about is the things that we're not taking into consideration. It's taken this
Mm.
long for me to figure out that, oh, I've been designing buildings looking at the past and I need to be looking at the future because that's where this building is going. It's not going to the past. So it's never going to be able to experience 1970 or 1950. It's going to see 2050 and 2125.
And if there's one or a couple of mindset shifts you'd like architects, planners, or policymakers to take away from the conversation, what would they be?
We have to communicate with people and find them where they're at. We don't need to talk about climate change and global warming. We need to talk about beautiful architecture that's relevant to a certain place, that being a climate and a culture, and provide people that identity that they can connect with and give them the beauty that they want. And oh, by the way, it is sustainable, it is resilient, it saves you money, and it does what we need to do today with the technology that we have to address the climate crisis that we are already in. For a long time, I thought climate change and global warming, that's something for the future. So it's cool. We'll do what we can now. But 2023 for me and the fires here and the things that I've seen in my life, I can't put my head in the sand anymore. It's here. Like it is happening now. So we have to do something about it. But we have a messaging problem. So we have to change our messaging. I like to say that sex sells, right? We know that in humans. So we have to make sexy architecture. It also needs to be resilient. And the resilient includes all of those things I just talked about. And it has to be responsive to the climate in the future, but it also cannot discount economic. I want to provide buildings and I want to inspire people to design buildings that are beautiful and high performance. And I want to focus on the beauty. So I want people to like it because it's beautiful. And then they'll hopefully, because there are negative connotations to being off grid or having solar panels, I want them to be able to look past that because it's so beautiful. The other thing that we're trying to do is we are trying to integrate renewable energy into buildings. One thing that we like in our culture, and we find it in our art responds to where we are as a society. So if you look at when the camera came out 100 and some odd years ago, we had this change in art, and now we have sort of cubism, expressionism. We kind of backed away from making sort of the Rembrandt photorealistic images. Now the zeitgeist is okay, well, how can we express ourselves? We don't need to recreate what a camera can do because it's already doing it. So now I'm curious what we're doing now. Like we are in the midst of a digital revolution. That's why it's really exciting to be practicing architecture now. I graduated undergrad and my thesis was hand drawn. I was on the cusp. It was like, wow, we have AutoCAD. Shortly thereafter, 3D modeling is just ubiquitous. And so that's why I went back to school and learned sort of the more modern digital tools. It's changed so much since then.
Mm.
So we need to be constantly taking that into consideration, applying that to our craft. Because again, if we can influence up to 50% of carbon emissions, we should be doing something about that. I often joke we should just get together as architects and designers and say, look, let's all make a pact that we're not going to build any buildings that are a detriment to our climate. So we're going to build only net zero buildings moving forward. If we all say that and a client comes to you and they say, oh, I want you to build me a building, and say, okay, it has to be net zero. And they're like, no, I'm not into that. And they go to the next architect, and the architect tells them, hey, it has to be net zero. And the client says, oh, I'm not into that. And they go to the next one. And then they maybe get the picture like, I don't have a choice anymore because these people have ethics, values, and morals that they find important and they stand behind. And if we all do
Mm.
that, we all say we're going to build a safe building. There's not an architect in the world that says, I'm not really into safe buildings. I'm going to build you, a really unsafe building. Well, is it safe to have a building that is going to contribute to climate change? Right now, we're looking at millions of people in the next several decades that are potentially going to be displaced by climate change, sea level rise, temperature, droughts, etc. That is not a stable, safe way to conduct society. So we have to start being proactive about that. And we don't need to necessarily browbeat, say, we're doing this. We just need to put that into our sort of design skill set and make that a key principle of how we're designing. Some clients, we can say, look, this is what we're doing. So we design mass timber buildings. So some of our clients are like, wow, I've got a building that sequesters more carbon than it takes to construct it, and it's never going to emit carbon in its lifetime for its operation. Some people are really into that. Some people really like the look of wood, like, whoa, that's really beautiful. So let's just stick with the beautiful wood. And if we find those people that feel the same way that we do, then we can talk and sort of preach to the choir. But in the meantime, we've got some real work to do. We need to message this to the rest of the population, and we need to sell it. And like I said, sex sells, right? So it needs to be sexy, it needs to be attractive. And oh, by the way, it's good for the planet and it's good for future societies and future generations.
Well, with that in mind, David, if you could have any person or character, alive or dead, real or fictional, as a champion for climate resistant housing, who would it be and why?
Mm. I've always been a fan of the author Aldo Leopold, Sand County Almanac. When I was young and I read that, and it was kind of documenting some of this climate change, and it kind of opened my eyes. So I've always wanted to design a museum for him or for that kind of thinking, that early thinking. In a way, I think that I could learn from it on how to relate that to our current day. So, yeah, that's one of my heroes. And yeah, I think that would be the person.
Great. Okay. We're coming towards the end of the podcast now, David. Is there any question that I didn't ask that you wish I did, or any aspect of this we haven't touched on that you think it's important for people to think about?
No, not necessarily. For me, I think coming from Texas, my life view, political views vary greatly from probably the majority of the population. But at the same
Okay.
time, I realize that we focus too much on our differences and not the things that we have in common. The unique thing about growing up in a more conservative place, and now my ideas and values are attributed to more liberalism, probably more environmentalism, but there's a real connection there. My love of the environment, my worry that we're destroying it faster than it can repair itself. There are a lot of people that enjoy fishing, hunting, and hiking and camping and being in nature. And they
Yeah.
have maybe different political views. So let's stop talking about our differences and start talking about the things that we have in common, because there's more of that than there are the differences. And we can all get on board with it. Organizations like Ducks Unlimited, yes, they are funded and supported by hunters, but they're also one of the largest conservation organizations in the United States, with millions of acres that are conserved of critical riparian and wetland ecosystems, right? So we've got friends that we don't necessarily agree with everything on. Let's stop trying to agree on everything, and let's focus on the things that really are going to affect our children and our grandchildren. We have the technology, we have everything that we need today to do it. The only thing we don't have is the will. So we just need to work on that part. The technology continues to be there, be available, and affordable. So we just got to keep going, keep trying. And I really appreciate the opportunity to talk with you and the conversations that you're having. And this is really important. So thank you.
Mm. Thank you. Thank you. If people would like to know more, David, about yourself or any of the things we talked about on the podcast today, where would you have me direct them?
Sure. Well, the interwide web is the best place to do that. HawaiiOffgrid.com is our website for our studio. And then surfblockmaui.com is our website for our building product. We'd love to hear from folks if there's something that we can do for you. We also practice architecture on the mainland. I'm licensed in several states. So we're always looking for like-minded people that we can collaborate with, is what we do.
Fantastic. Great. David, that's been really interesting. Thanks a million for coming on the podcast today.
Thank you. Look forward to talking with you soon.